Okay, so number 16 on the chapter review assignment. What we're going to do is prove this one here. Okay. What we're going to need is to get these triangles congruent, and then we can get those. So it says angle 1 is congruent to angle 2. Now that's strange because 1's also congruent to angle 3 because of vertical angles. So these two are vertical. And then we're going to eventually get those two the same. Now 4 is the same as 5, and we can use reflexive. So we're going to write this down. Triangle JKL is going to be congruent to triangle JML. And that's going to be using the angle side angle triangle congruence theorem. Okay, so that's where we're headed. Let's see if we can get that done. So we got the statements over here, reasons. All right. First, I need angles, right? Now let's go with the easiest ones first. Angle 4 is congruent to angle 5. That's going to take no work. It's just given. Okay, so those are nice. Now the next pair, oh, well, let's go for the sides, right? Let's go in order. Now we're after a pair of sides. JL is going to be congruent to itself. So we call that, the reason we're allowed to say that is because it's a reflexive property. If you forget that, no worries. Just explain it. Side is congruent to itself. Okay. Number 3, now we have to work for these other pair of angles. Not going to be easy. Okay. Angle 2 is congruent to angle 1 because it was given. All right, this is going to be a little weird series, but you'll see this. Angle 1 is going to be congruent to angle 3, and that's because vertical angles are congruent. Don't just say vertical angles here. Please finish it with theorem or are congruent. Okay. Number 5. Now what you're going to do is take those two combinations, right? If 1 is the same as 3, we can replace angle 1 there with angle 3. So we're going to rewrite this one, except we're going to sub in angle 3 in place of angle 1. That's by, we can actually say that, substitution. That's actually a legitimate reason. Okay, now the triangles are the same. And that is by angle side angle, triangle congruence theorem. All right, and then we can say that last step that we wanted. KL congruent to ML, and that is by, again, that corresponding parts of congruent triangles are congruent. All right, that's pretty good. That one's all set. And we'll move on, okay, over to here. All right, so this looks like one we've already covered, but it is different as far as the givens go. When they say xz is perpendicular to yw, what you end up getting is a couple right angles there. Xz bisects the side wy. Okay, now we're going to get two congruent sides there. Okay, we're going to have to prove xz bisects y xw. All right, that's our goal. So it's not true yet. Okay, we got to prove that basically these are the same. Then we can use bisect. All right, I'm seeing a decent idea here. Got a pair of sides, pair of angles. What if we threw reflexive in there? I think we'd be all set. So what I'm going to try to do is I'm going to try to prove that triangle XOY is going to be congruent to triangle XOW. And that is by, looks like side, angle, side, triangle congruence theorem. So that's my pre-proof and my plan. So let's go ahead and do that. So we got statements and we've got reasons. So our first statement, we're looking for a pair of sides. Okay, let's use the bisect one. So we're going to take the bisect WY first. We got to write it down because we're going to use it. Okay, so WY is cut in half. That's given. Now let's draw an inference or a conclusion from that. From that, WY is cut in half to YO is going to be congruent to WO. Okay, and that's because of definition of segment bisector. All right, now we go to 3. That gives us a pair of sides. Now we want a pair of angles. Got to work at this a little bit. This is going to be a lot trickier. So XZ is perpendicular to YW. Okay, that is given. Now a conclusion from perpendicular is always right angles. So we got to use the 3-letter path though. We're going to say angle YOX and angle WOX. Technically, we've got to say they're right angles first. And that's because definition of perpendicular or perpendicular segments form right angles. Okay. A conclusion from that, since we're not trying hypotenuse leg, we're actually trying side angle side. The A requires us to get a pair of angles congruent, so those now have to be congruent. Okay. And that is because all right angles are congruent. Some might say right angle congruence theorem. All right angles are congruent is what I'm going to write. So you don't have to memorize all these theorems. You can just explain them if you forget what they're called. So that gives me a pair of angles. Now I want the pair of sides. I'm going to say XO. It's congruent to XO. That's our reflexive property. Okay, that side is shared by both triangles. All right, now we're going to say the triangles are congruent. It's a lot. We proved XOY is congruent to XOW, and we said that was by what? Side angle side. Okay, we still got 2 to go here. All right, 2 to go. 8. Looks like we need, okay, so to bisect an angle, we need 2 congruent angles, YXW. Okay, so we're going to need these 2 angles. Now they're congruent, YXO, WXO. Angle YXO is congruent to angle WXO. And that's that corresponding parts of congruent triangles are congruent. Okay, all right, and to finish it off, angle, wait a minute, no, sorry, I forgot what it was, XZ bisects, okay, angle YXW. That's because those angles are congruent, so they were bisected to create congruent angles. Now, the whole purpose of definition of, it means it works both ways. So now, I'm saying we have congruent angles, which gives us the fact that we must have had a bisector, okay? Or the other way definition works is it means if you have a bisector, you get congruent angles. So definition means it can interchangeable. It can go either way. So it's definition of angle bisector. Okay, they were congruent angles, and they must have been because of a bisector. Okay, so that's it for the proofs, and we'll do the other problems on a next video.